Hello, this is Network of Resistors. In this lesson, we are going to learn how to evaluate what we call the equivalent resistance and then the current and voltage in a given network of resistors, either connected in series or parallel. So ang buhato nato din nga lesson is that mahibal-an nato kung saan pagpangita sa resistance, current ug voltage sa isa ka combination sa mga resistors. Okay? So first recall that the cross-sectional area of the resistor is inversely proportional with your resistance. That is why when area is doubled, so kung nag-double yung area, ang sinahitabo sa resistance, nahimo siyang half na lang. Doubling the area lowers the resistance by half, inversely proportional. Now, consider that kini siya resistor man siya no. In the diagram, it will be like this. Consider two resistors R1 and R2. When you connect them in parallel, so resistors connected in parallel, so kana siya, pwede na ito na isulod og box having a resistance equivalent to Req. Mo siya gi-combine mo ba? Sulod na nimo siya box diha. So ang iyahang resistance now is Req or equivalent resistance. How can we compute that equivalent resistance? First, let us know that because this is i-combine man sila ani unsay nahitabo, ang flow sa imong kurente sa tanan sa combination is a sum. So sa duha ka suba, so na kay current across this, so I1 and plus I2. So what happens, recall that your Ohm's law gives I equals V over R. So that is why we have it here in symbols for all. But note that because they are in parallel, so unsay mahitabo in basta in parallel, ang imong higher potential og lower potential parehas lang sila og distance. Therefore, di ba parehas naman sila og length. So, ang nahitabo is these values are the same. VQ equals V1 equals V2. Pwede na to i-assign na siya og constant V. So divide all of these terms, ma-maintain mo ang equality, so mawala ang katong V inani. So we can compute the equivalent resistance using this equation on saan man. So Req, so 1 over Req equals R2 plus R1 by common denominator R1 times R2, then i-reverse na nimo. So R equivalent is equal to R1 R2 reciprocal plus R1. Okay? Kuha na to. Okay. So the next one is for your recall also that so this is your length of separation in flowing from higher. This is a higher potential. This is a lower potential. When the length is doubled, since the length is directly proportional with your resistance, the resistance is also doubled. Doubling the length doubles the resistance. Now we look at it uh, as resistors connected in series. So what happens? So consider this as your R1 and your R2. In symbols, in the circuit diagram, it will be like this. So what will happen now? So we're going to connect them along the same line. So their length has been doubled. Or here in the diagram, naka-connect ang isa lang nila ka-end, but their other ends naka-connect sa higher, ang isa sa lower potential. So what happens? So in this combination, since ang imong higher or lower potential natunga man din so ang imong for your V1, this is the lower potential of your V1. However, for your V2, muna po na ang higher potential sa V2, this is the lower potential for your V2. So it's a sum. So the combination's potential is a sum. Recall your Ohm's law is V equals I R. So that is why we have it here. So na ay kana siya mo ni. For the V1 mo na siya, for your V2 mo ni. And then note that since they are along the same line, so pareha ang ilahang area. Unsa may mahitabo kung unsa ang modaloy dinhi, same pud ang modaloy dinhi. So same na delta Q delta T. Therefore same current. So I equals I2. So recall for parallel connections, same volts. This is only for resistors, okay? Resistors. But for series, same current. So because of that same current, so we can divide all of this by I, and we arrive in here. This is simple. Mag-add lang ka. No? So remember, resistance in series have the same current. Resistors in parallel have the same voltage, or what we call as potential difference. In this example, so we are going to combine all of this, and it will become like that. First, ato sang i-combine ang katong obvious nga connection. First, i-combine nato ning tulo kay klaro man no, pareha sila connected in parallel. Both of their ends naka-connect. So kini siya nahimo siyang R234. Okay? And since they're connected in parallel, unsang equation nga gonna govern inani, di ba? Reciprocals. The sum of the reciprocals equal to the reciprocal of the equivalent. After that, so once nakuha nato ni, since they are connected in series now, your equivalent resistor for the three resistances is in series with this R1. Therefore, pag combine na po nimo na lang duha to become this. So, i-combine na nimo kana sila mahimong kanina lang. And the governing equation is this one. Nakuha ba? For this example number 2, so muna siya ang given. So ang mahitabo is, again, you're going to combine those connections which are obvious. Kini silang duha, unsa man parallel, really? No, not ba. We don't know. But there is an obvious connection here, kini silang duha. Diba? They're connected in series. Isa lang, no? Isa sila ka-line. They're connected in series. So what you're going to do is combine them to arrive at that. So pag combine na po nimo, nakita na to nga parallel silang duha. So i-combine na po nimo ni mahimong ato na lang. So nakita na to, their combination is now in series with R4. So i-combine nimo ng duha and you arrive at your pinaka-combine na gid nga mga resistances. So what we have here is that first you can compute this R12 from that combination. Since they are connected in series, sum lang diretso, di ba? Then R12 and R3, pag combine mo, nahimo siyang R123, the governing equation is this. The last one, since they are connected in series, by the way, nasayop ko. So 1, 2, 3, this is. So notice my use of subscripts. Ako siyang, whenever I combine 1 and 2, ang subscript na ako is 1, 2. Whenever I combine the combination of 1, 2, and 3, so ako pong gikuha ang 1, 2, 3. So here, one of the techniques is to be systematic in your labeling. So in this example number 3, we are going to have an actual computation. So we now have values. We have 3 ohms, 2 ohms, 3 ohms, and then 8 ohms. The question that we are going to answer is the equivalent resistor of the network of resistors. No? Unsa gini siya kung i-combine na nimo tanan. unsay value sa ihang resistance. So first is we need to label first. So muna first step, because we are going to solve an equation, it is better not to carry these numbers but instead use symbols. So let's have R2 to represent the 2 omega, R1. It's up to you. Ako, sa nasa ko lang. So you have the freedom. So after that, since we already have our labels, look at that. So we can see an obvious connection here. R1 and R3 connected in parallel. So, pag combining mo, nahimo siyang R2, 3. The governing equation is this one. So, let's compute. So, what is R3? This is like your your R3 is this one, the 3 ohms. So, 3 ohms ang imong R3, and then your R2 is 2 ohms. And then, so, common denominator, so simply multiply both denominators, then divide 6 divided by 1 is 2, 6 divided by 2 is 3, and then we add, so 5, this one is 5, this one is 6, 5 over 6, this is omega, and in your denominator is omega squared, so makancel ang isa ka omega, so nahimo na lang siyang 5 over 6 omega. Then notice nga reciprocal pa na siya, kinahanglan pa nimo kuhaon ang ihang reciprocal, and then you arrive at this one. So we have the answer for that combination, but we are not finished. We need to continue as we combine this one with R1. Unsa ilang connection, diba? Isa lang ka end ang nag-connect sa ila. Isa sila ka linya, they are connected in series. So this is the governing equation for their equivalent resistance. So simply add 6 over 5 plus 8. So this becomes 6 plus 40 over 5, di ba? So, munang natin 46. Okay, that's all. Thank you.